I welcome you to the second session on circular races. In the first session, we saw one simple question and how to solve that simple question. In this particular session, we will take a look at one more variation of questions based on circular races. Now, suppose we have two people, A and B, who travel in the same direction, say a clockwise direction, around this circle. In the previous case, we saw how to calculate the time when A and B together are at the starting point. And the given information is the value of this circumference, the value of the circumference of the circle, and speed of A as well as the speed of B. In this particular question, we want to find out when will A and B be together for the first time, not necessarily on the starting point, but anywhere on this race course. So, how do you solve this question? If the question were, when will A catch up with B for the first time? And for the first time, it is not necessary that it takes place at the starting point. Now, to solve such a question, we need to understand that if speed of A is greater than the speed of B, and if A and B are running around this circumference, then when A overtakes B for the first time, A must be exactly one circumference ahead of B. And when A overtakes B for the second time, A should be exactly two circumferences ahead of B. Now, this is the inherent principle that we will use to solve the question. But first of all, let us understand why do we say A is exactly one circumference ahead of B. Let us assume values. Let us say the value of speed of A is 20 meter per second and the value of speed of B is, let's say, 8 meter per second, and the value of circumference is 120 meters. So let us take these values and let us see what happens. So at what time will A complete one revolution or A complete one circumference? A completes one round in 120 divided by 20, that is 6 seconds. And where is B? So after 6 seconds, B must be at a point 6 multiplied by 8, that is at 48 meters. So let us mark out this point S1 at 48 meters. Now, because A completes the first round in 6 seconds, A will complete the second round in 12 seconds. And after 12 seconds, B is exactly at 48 into 2, that is 96 meters, at say another point S2. So we can easily see that between the point S1 and S2, A will overtake B somewhere. Let's say A overtakes B at another point, let's say point P. So when A overtakes B at point P, the distance covered by A is equal to one full circumference plus anticlockwise from S to P. Anticlockwise from S to P. Whereas the distance traveled by B at the same time is only anticlockwise from S to P. So you can see here that when A overtakes B for the first time at point P, A is exactly one circumference ahead of B. So this is a point you need to understand before you can solve any questions. So let us summarize that, and we have when A overtakes B for the first time, A is exactly one circumference ahead of B, And when A overtakes B for the second time, A is exactly 2 circumferences ahead of B. So that brings us to an important conclusion that if A and B run around is this circular race course in a clockwise direction, then after how much time will A overtake B? Because we just now saw that A will overtake B when A is ahead of B by 1 circumference. And it is known that speed of A in this particular case is greater than the speed of B. So let us try to identify that. So as I just told you that A will overtake B after a time that is equal to time required by A to move ahead of B by a distance equal to 1 circumference. And because A and B both are in motion simultaneously, relative speed will come into picture. So what is the relative speed between A and B? Because they are both moving in the same direction, the relative speed between A and B, designated as SAB, will be equal to speed of A minus speed of B. And what is the distance by which A goes ahead of B? That distance is C. So we have the time after which A overtakes B must be equal to distance divided by the relative speed, and that must be equal to the circumference upon SA, the speed of A, minus speed of B. So we can easily draw this inference that when A overtakes B for the first time, and when A is and B both are traveling in the same direction around a race course, the time after which A will overtake B is calculated as time t is equal to the circumference C divided by the difference of their two speeds. So let us now solve one question based on our concept. A and B move around a circular race course 400 meters in length at speeds of 20 and 25 meters per second. After how much time will B overtake A? Both are traveling in the same direction. So we have two individuals, A and B, travel in the same direction around this race course, and this race course is 400 meters in circumference, and we want to know when will B overtake A. It is given that B's speed is 25 meters per second and A's speed is 20 meters per second. So we've just now seen two things. Number one, when B overtakes A for the first time, B will be exactly one circumference, that is 400 meters ahead of A. And therefore, the time after which B overtakes A should be equal to the circumference upon the relative speed between B and A. And this is equal to 400 upon 25 minus 20, and that is equal to 80 seconds. Now what would have happened if A and B had moved in opposite directions? In that case, the question would remain the same with only a minor difference, that the time required would be equal to the circumference upon SB plus SA, because what would change in that case would be the relative speed between A and B. The rest of the question would remain the same. That is, when A and B traveled in opposite direction and when they meet for the first time, the total distance traveled together will still be one circumference. So with this we come to an end of our session. If you wish to know more or solve more questions on the same concept, please log on to our website www.pfindia.com. You could also write your doubts to us on studentservices@pfindia.com, or if you're using this particular video on our website, you can use the Ask a Doubt feature to ask us any queries. Thank you very much.